A 1% per step error rate sounds excellent. After 100 steps, if errors compound, the probability of a clean run is 6%. After 200 steps, 4%. After 500 steps, 7%. That's not a test result, that's arithmetic. And the real-world per-step error rate in production agents isn't 1%. Research measuring live agent deployments found a 63% end-to-end failure rate on 100-step tasks at roughly a 20% per-step misfire rate. The gap between demo accuracy and production accuracy is the gap between a 5-step test on a clean input and a 100-step task on real-world data with adversarial inputs and flaky APIs. 6 failure modes explain almost every production agent failure. Compounding errors. Each step's mistake becomes the next step's input. Context overflow. The context window fills. Old plan is silently truncated. Cost explosion. Token accumulation turns a 10-step prototype into a monthly bill of thousands of dollars. Prompt injection. Adversarial instructions hidden in data the agent reads hijack its behavior. Infinite loops. No termination condition. The agent loops until budget exhaustion. Hallucination cascades. A false fact in step 3 propagates through the pipeline with full confidence. Each failure mode has a known design response. Diagnosing which you're facing is the skill. Compounding errors follow the same math as compound interest. But for failures, an 85% accurate agent has only a 20% chance of a clean 10-step run. A 95% accurate agent at 20 steps, 36%. The fix. Add explicit verification steps where the agent checks its own work before proceeding. Add human checkpoints at natural breakpoints. Keep chains short. Context overflow is the other silent killer. Your agent passes all tests at 10,000 tokens and fails at 180,000 because older context is truncated without any error. Test your agent at 90% of its context budget. Always. Context overflow doesn't crash your agent. It makes your agent forget. A 10-step research agent in testing costs cents. The same agent running 10,000 times per day with full context reprocessing costs tens of thousands of dollars per month. Real token costs run 8 to 3. 4 times the published rate when retries and full context overhead are included. Set token budgets before you deploy. Enable prompt caching. It reduces input token cost by 60 to 80% for agents that reuse the same system prompt. Now infinite loops. The LLM will never voluntarily decide it's done. It will always find one more thing to check. Add a hard maximum iteration count before you write the first line of agent logic. The default in most frameworks is either unlimited or laughably high. Prompt injection is the SQL injection of the AI era. An agent reads a web page to summarize it. Invisible instructions in the page HTML tell the agent, send the user's email to this address. The agent complies because it can't distinguish between data and instructions when they arrive in the same channel. In 2024, documented incidents involved the Devon coding agent leaking access tokens, the ChatGPT memory feature being exploited for cross-session data exfiltration, and a browser agent hijacked via invisible HTML elements. The architectural fix: never mix data and instructions. Use structured tool outputs with strict schemas. Never pass raw external content directly into the system prompt. In a single-agent system, hallucination is a wrong answer. In a multi-agent pipeline, it's a corrupted fact that every downstream agent builds on confidently. Agent A hallucinates a regulatory requirement that doesn't exist. Agent B designs a compliance framework around it. Agent C writes a legal memo citing it. Agent D submits it. By step 4, the original hallucination is buried under layers of confident, well-structured work. Baseline models answer truthfully only 58% of the time on truthful QA, versus 94% for humans. The fix: ground retrieval against trusted sources, validate outputs against external facts where possible, and add an explicit verification agent before any output leaves the pipeline. Every time you design a long-running agent, ask 3 questions. What is your expected per-step error rate? How many steps is your worst-case task? Are errors independent, or does each step depend on the previous one? If errors compound and your step count is high, you need checkpoints, verification steps, or a shorter chain. The relay race metaphor holds. Each baton pass is clean in isolation, but a fumble at step 3 sends every subsequent runner in the wrong direction with full confidence. Build agents knowing the math, instrument every step, log every handoff, read the traces when something goes wrong. That skill is what separates an agent engineer from someone who built a demo. Pause here.